Hello friends, in this video we will be discussing electric charges. So my name is Iitjee Sharma and let's start with the charges. Charges is a property due to which particle experiences electromagnetic forces. We can have few properties of the charges. We found only two types of charges in nature and we named them as positive and negative because of their additive nature. Okay. So we found only two types of charges and we named them. Okay, these are their names. Like charges repel, we also found that like charges repel or unlike charges attract. Means plus plus will repel, minus minus will also repel, plus minus will attract. Mobile charge is basically the particle, mobile particle is basically the electron. Whenever you rub two objects, few electrons from one object moves to another. So, and the charge on that particle named as electron is negative. Okay, so the mobile charge is negative. Electron is the name of the particle carrying it. Charge transfer is always associated with mass transfer. As we are transferring the charge, mass will also transfer because electrons will move from one place to another. Net charge on an isolated system is conserved. Let's say this is an initial system in which A and B are two objects which both are neutral, and if we rubbed against each other, let's say charge on A is plus X, then obviously charge on B will be minus X. Mass of A has decreased because electrons has transferred from A to B, and MB has increased by same value. Okay, and QA plus QB must be 0 because the initial charges were total 0. Phi, it is the work function. The body or the object which takes the negative charge should have a greater work function. So it is very hard to take out electrons from B as compared to A. So the electrons are moved from A to B whenever they are being rubbed against each other. So in this case phi B is greater than phi A. जो भी ऑब्जेक्ट नेगेटिव चार्ज ले लेता है उसका वर्क फंक्शन ज़्यादा होता है, क्योंकि वर्क फंक्शन बेसिकली एक ऐसी प्रॉपर्टी है जो डिसाइड करती है कि इलेक्ट्रॉन निकालने में कितनी एनर्जी चाहिए. तो अगर B से इलेक्ट्रॉन निकालने में ज़्यादा एनर्जी चाहिए और A से कम, तो A के इलेक्ट्रॉन निकल के B में चले जाएंगे. The next property is charge is quantized. Charge can exist independently only as form of Q equal to plus minus Ne. Okay, so now you will talk about quarks. Quarks are not stable components. Obviously quarks has a charge like 2 by 3e or 1 by 3e also. Okay, so but they don't exist independently, so we will not take these into quantization. So the charge may exist only as Ne. We'll talk about quarks later. So we have to comment which of the charges will exist or not. Let's start with the first one. Put it equal to Ne. Just say if n will be an integer, n should be an integer. If n will come out to be an integer, it will exist. If not, then it will not exist. So in case 1, 8.0 into 10 to the power minus 19 when divided by E, which is 1.6 into 10 to the power minus 19, we get 5. 5 is an integral, so it will exist. In the next case, when we put equal to Ne and try to find out the value of n, we get 1.6 10 to the power minus 19. We get 5 by 1.6, which is not an integer. So it will not exist. This charge will not exist. But 5 microcoulomb equal to Ne, when we start solving this, divided by 1.6 10 to the power minus 19. This is now minus 6, this is now minus 19. In the previous case, both were minus 19. Okay, so we'll get 5 into 10 raised to power 13 by 1.6. Obviously this will be an integer and the value will be 3.125 into 10 raised to power 13. Obviously this is an integer and a very large integer because of this high value. So we can say we need not to check quantization in larger charges, microcoulomb, even nanocoulomb are larger charges as compared to E. But in very small charges like this, 10 to the power minus 19, we should verify the quantization. Okay, so no need to verify quantization in larger charges. If you'll ask that 3 coulomb will exist, I'll say yes. If you'll ask 3.125 coulomb will exist, I'll say yes. If you'll ask 4.32 microcoulomb will exist, I'll say yes. Okay, all these values, 5.55 microcoulomb will exist, yes. So these are larger charges, so they will exist no matter what the value is. Last part is 3.2 into 10 to the power minus 20. See, this is minus 20, and when we'll put equal to this and try to find the value of n, we will get only 3.2 by 1.6, 10 to the power minus 1. 0.2, it is not an integer, so it will not exist. Charge is invariant, means the value of charge is same from all reference frame, whether the frame is moving with a very large speed or small speed. For your information, length, mass, time are variant physical quantities as per relativity. If you run very fast, means velocity is comparable to c, the length will contract, mass will increase, time will slow down. These are the observations from relativity, which is not the part of this discussion, but charge will remain same even if you are moving with a very high speed also. Okay, thank you.